Hey everyone, I wanted to record a video for you here for today. Not feeling really well today, so I apologize for the voice quality. Seem to have caught a cold and got a little bit of an ear infection, so bear with me on this, okay? Doing my best to hang in there. Um, as we started studying this unit on triangles, kind of the focus has been like, how do we know if the triangles are congruent or not? Okay. And so I want to start with just the kind of basic congruency statement. So, like, if we know that we have two triangles, for instance, triangle ABC and triangle DEF, where every set of sides has a corresponding set of sides on the other triangle that match up with it. So, like, AB is congruent to DE, and then AC and DF are congruent, etc., etc. As long as every set of sides is congruent to another set of sides on the other triangle, and every set of angles is congruent to another set of angles on the other triangle, then by default the triangles have to be congruent because everything matches up. Okay, so first things first, we'll start with just some basic ideas here. So basically, we're going to say congruent triangles have three sets of congruent angles and three sets of congruent sides. And you can see that in this picture. So these two triangles here have to be congruent because of the markings. Okay. Now, a lot of times on the quizzes and the tests and the homework, I'm going to ask you to write congruency statements. And these are very simply just matching parts up. Okay, so I'll give you an example. So let's say I start with triangle ABC, or actually I'll go in a different order. Let's go BCA. Okay, we could say triangle BCA is congruent to triangle. Now we got to be careful because everything is matching in this congruency statement world. So if I start with B, B is the bottom left corner. Over here, I would have to start with letter E. So I would say E, and I went to letter C next. So C is the bottom right. So, and that only has one marking on it. So that would correspond to letter F and then D. So we can go in any order you want. You just really have to watch the way you pick your letters. All right, now, and I'm going to carry on with this now in such a way that you're going to see why you really don't even need the picture anymore. All right, so I'm going to cover the picture up. And we can also have congruency statements about the angles. So if I pick angle B would be congruent to, well, since I picked B first, I'm just going to look at what I listed first here. So angle B and angle E would be congruent because of the way they're written in this congruency statement. All right, we can continue on. Let's say I pick angle F. All right, angle F would be congruent to, well, let's just look. F's in the middle, C's in the middle. So angle F and angle C are congruent. And then the last letter, angle A, since it's the last in the list, would have to match up and be congruent to angle D. So it's all based upon where the letters are located relative to one another. And the same thing is true for segments. So these were the angles. The segments, if we pick B, let's say, for example, BC, segment BC is congruent to, whoops, oh shoot, sorry, my pen's acting up. There we go. BC is congruent to, well, if we look over here, BC is the first two letters. So E and F would be the first two letters, so we'll say segment EF. So it's just a matching game, all right? Let's say we pick DE. So segment DE would be congruent to, well, DE are the first and last letters. So over here, that would be A and B. So it would be segment A, B. Now you could have even said BA because remember, segment order doesn't matter. So you can even check the triangle now. So BC has two markings. EF has two markings. Yep, that means we did that correctly. DE has 3 markings, and so does AB. So we certainly could have referred to the picture. I just wanted you to realize if you have a congruency statement like this guy right here, you don't need the picture. You can just look right at that. Okay. So do we have to know everything about the triangle? And in fact, we don't. And so these shortcuts that we're going to learn today, you hopefully got a really good feeling for these the other day when we did that Billy Bob's Roadkill activity where you built triangles. The funny names that they had picked out really didn't didn't obviously stand for the slimy sausage, whatever it was called. It was actually representing like parts of the triangle. And so when we talk about SSS, we're really talking about a congruency that's called side, side, side. So I'd like you to jot that down on your notes. And basically the way side, side, side works is you're going to have 2 triangles. And, they might be pushed up next to each other. They might be mirror images. They can be drawn any way, shape, or form. But essentially every set of sides has to have another triangle that was drawn the same way. But the kicker for this one is we don't have to know anything about the angle. So right now, these markings indicate that each set of sides matches up on both triangles. So here we'll say for our description, we'll say both triangles have 3 sets of congruent side lengths. And by knowing that, again, we don't know anything about the angles, but just knowing that there's 3 congruent side lengths, then we can conclude that the triangles are congruent. Okay, so this is a shortcut. We didn't have to know anything about the angles. All right, now side angle side is the next one. Side angle side is going to be abbreviated SAS. All right, so that's side angle side. And notice how many letters we see of each kind. Also notice where they're located. Okay, so on this one, I'm going to draw the triangles kind of like this. Okay, whoops. Trying to make them like the same. Okay, so on this one, notice we have 2 S's. So that means we have to pick 2 sets of sides that are congruent. So it doesn't matter which ones, we just need 2 sets of sides. Okay, but the way the angle is located, the angle has to be, I call it like the hinge angle. So let's just say these are the 2 sides that we marked as congruent. I like to trace those 2 sides. Okay. Wherever they meet, which in this case is at the top vertex, that's the angle that we'd have to know is congruent on those 2 triangles. So it couldn't be either of these bottom ones. It has to be what's called the included angle. So the description here will say, it says if we have the following sets of matching congruent sides, we have to have 2 sets of sides congruent, and what we're going to call the included angle, if you want to put also known as or AKA, I'm going to call that the hinge angle. That's not really a geometry term. I kind of made that one up, but that's how I think about it. It's like, think about it as like the hinge. You set it at a specific angle, and it has to match what the other one's set at. When we see that, the triangles are congruent. Okay, we don't have to know anything about the other sides or the other angles. All right, ASA, you can probably guess now, that's angle, side, angle. And angle, side, angle is going to look something like this. You can probably guess how many sides and how many angles. So angle, side, angle is going to have 2 angles marked. So again, let's just pick 2 angles. Let's say this bottom left one, and let's say this top right, or the top one. Okay, let's say we have those 2 sets of angles marked as congruent, or built the same. Like if you were kind of like the triangle activity. If those are the angles that were built the same, the S in the middle means that the side that joins those two angles, which is right here, that's the side that we'd have to know the length of. Okay, so how would we describe that? We would say we have two sets of congruent angles and one set of included sides that are congruent. Okay, when you see that setup, then this is going to look pretty familiar. Then we know that's enough. That's a shortcut, and we know the triangles are congruent. Okay. ASA looks a lot like the next one, but the order is different. So let's build two triangles here. So just like before, we will have two sets of angles that match up. All right, and again, I don't care which ones you pick. We just need, since there's two A's, we're going to have two sets of angles. Okay, so I'm going to mark something like that. I'm also going to come over here and I'm going to say angle, side. All right, now, this side, there's only one side we can't pick, and I'm going to highlight the side we can't pick. This is the side that's considered included. Okay, and since, you see how the S is on the outside here? Okay, since the S is on the outside of the A's, it's not in the middle like it was up here. That means the side that has a marking can't be the one I highlighted. So it could either be that set or this set. It doesn't really matter. Just one of those has to be selected. All right, so what do we need to know? We need to know two sets of congruent angles, just like before, and one set of sides that's not between the angles. In other words, it's not included. All right, knowing that information is a shortcut to conclude that we have congruent triangles. All right. Now, the last one is a little different because the H and the L look a little different than all the other A's and the S's. HL stands for hypotenuse leg. And as you probably can guess by the name here, hypotenuse leg has to occur on a right triangle. So I'm going to build two right triangles. So anytime you see a right triangle, check for HL. Most of the questions on this chapter in this unit are going to be dealing with two triangles with information marked. And we're just trying to figure out if there's enough information to show that they're congruent. Okay, so HL works like this. I'll describe it first. HL says you must have two right triangles. Okay? Must have the heights equal. Must have one set of legs that are equal or congruent. All right, so let's see what that looks like. You're going to have the hypotenuse. Well, the hypotenuse is across from your right angle. So this set has to be marked as congruent. And then any of the other ones that are left over can be congruent. So we could say like these left and right edges. So like this set and this set, that's one of the legs. So the hypotenuse and the leg, one of them, has to have a marking. So something like that. That would be HL. And if we see that information, then it's enough to show that you have congruent triangles. Okay? Now, there's only two situations that don't really work. And if you look around the room when you guys did those Billy Bob, those triangle activities or the sandwich things, SSA, I always call this one the bad, excuse my language, the badass, if you spell it backwards. The reason I call it that is, sorry, I don't mean to offend any of you. I just think it's a good way to remember. It doesn't work. It's bad because, and I'll just asterisk these out so we don't get in trouble for cursing, okay? But basically it works like this. So if you have two different triangles here, all right, let's draw two triangles. And we have two sets of sides marks. Let's just put congruency marks on two sides. So let's say this one and this one. I probably shouldn't have made it look like a right triangle, but I did. All right, the angle that is going to be congruent, if you notice the way the letters are written, the angle has to be outside of the two sides. So anything but here. We can't pick that angle. Let's say this angle here. Okay, now we have two sides and an angle that's not between them. I'm going to write that in words. You have two sets of congruent sides and I'll call it a non-included angle. Okay, whenever you see that, it does not guarantee the triangles are congruent. Look around the room, find that category from Friday. You'll see that the triangles hanging up there don't all look the same. All right, and actually the same thing happens with AAA. On AAA you have only the angles that are congruent. So like, you know, you got that angle that matches up. Oh, shoot. Okay, so let's say your top angles are congruent. Your right angles here are congruent, and I'll just mark this one differently. I'll put a tick mark. And this third angle is congruent. As long as you have three congruent angles, I mean, they're going to look a lot alike. They'll look kind of like miniature versions of one another. If you have three sets of congruent angles, they're going to look similar, but they're not congruent. They're not exactly the same size. And again, look back at the wall, find that category, and you'll see that, you'll see that those triangles are not congruent. Okay? All right, so the last thing we're going to do here is we're going to look at what you can and can't mark. But I'm going to pause right now, and we'll put the second video together because I need a break for my voice. So I'll resume here shortly. All right, thanks.